Hello everyone, I want to take a look at the relationship between e to the x and the natural log of x. You guys should be able to sketch these two functions out and see that one is the mirror image of the other. So on the one hand you have here that this is f of x equals e to the x, like that. And then if you were to sketch the natural log of x out, that will look like this. So there's your g of x equals the natural log of x. And it really is in your best interest to sketch these on your calculator. I'm not going to be able to do this justice. You can see this in your notes, so you'll probably get a clearer picture if you were to look there. So as I mentioned, if you have y equals x, and that's where you make your fold, you should be able to see that e to the x would lie on top of the natural log of x. So these should cancel each other out, right? So if you write them as composite functions, then you should be able to say that f of g of x should equal x. Right? So your f of x should act on your g of x. These two should unravel each other or counterbalance each other and just leave you with your variable. All right, so if I were to write this out using these two functions that we started off with, then let's see. F of x was e to the x, and it says take your g of x, and that's going to replace the x part in your f of x, right? So what you could do is you could rewrite all of this. You could say, I have here that f of x equals e to the x, so you could just leave it as is. And notice here your two major functions are f, and you're trying to take your g of x and force it into the x position. So it has to go right here. Okay? So what are you left with? Need an equal sign there. This is e raised to whatever g of x was. So if you look over here, you can see that g of x was the natural log of x. So this is e to the natural log of x. Okay, so I want to look at this closely because you'll notice the e acting on the natural log gives you just your variable x. So e and natural log cancel each other out and just leave you with your variable. Now you could do the exact same thing going in the opposite direction, and now say you're looking for g of f of x. Okay, also a composite function. So let's see, we know that g of x in general equals the natural log of x. Okay, so these two major functions match up, which means you should be able to make a substitution. Your f of x should be able to force out the x position, so it should be able to go right there. Okay, so we have to be careful because considering that these are composite functions, when g acts on f, acting on x, these two should unravel each other, and you should end up with just your variable x, like that. All right, so let me write down what g of f of x is. Again, the f of x replaces the x. So f of x is going to go right there, right? So let me go over here and remind you, f of x is e to the x. So what do we have? This is the natural log of e to the x power, and that's what equals your variable x. Again, when the natural log acts on the e, which is acting on the x, these two cancel each other out and leave you with just the variable. All right, I want to make a couple of points. One, really, and that is that notation matters, right? You'll notice the x was in the power here, which resulted in the natural log being in power for this one. So you got to be careful on how you write it. Don't bring the natural log to the base. That will be incorrect, and I will mark off. Same here, the natural log of e to the x is the appropriate notation. Okay? So what I typically do is I make note of what I see at the end, because this is the important stuff down here, right? And what I see here as well. And I'm going to rewrite it on my page just further down. Okay, so when I have e raised to the natural log of x, this will just give me my variable x. Okay? And when I have the natural log of e to the x, this will just give me my variable x. All right. So this is a really good spot to be in, because now we can start thinking about what happens when we throw numbers or functions into something of this sort. All right, so for example, what would happen if we tried to solve for e to the natural log of 237? Well, the e cancels out the natural log, and your answer should just be 237, like that. Okay, so what would happen if instead I had the natural log of e to the 594? Right, so now the natural log is going to act on the e, and those will cancel each other out and leave you with just 594. Right, so that's the general idea about how e and the natural log interact with each other.